Okay, I want to go over pages 18 to 20. Okay, so here on this one is describe the distribution. So we're going to do our shape, outlier, center, and spread. And we had done this first problem in our notes yesterday, and so we did the first one, so that one was already done. Now, taking a look at this one, first kind of analyze the shape. And, you know, it's not going to be perfectly symmetrical, but this one over here is definitely skewed left. So we're going to go with that this is unimodal and more symmetric, okay? So that's our shape. So you need to write the word shape, and then that's unimodal and symmetric. Now, I ended up having a mistake on this answer key that I've got here, so I'm going to fix this as I go along. And so because you have symmetry, then the measure of center that you should choose to use is mean. And the measure of spread that you should choose to use is standard deviation. Because symmetry, standard deviation, and mean. See, if you have skew, then you must choose to use median and IQR. Okay? Symmetry, standard deviation, and mean. So, then when I come down here to center, the center I will write the word that the mean is, and it's 62.3. And that the spread is a standard deviation of 35.6. Now, after I have done that, then I need to go ahead and compute the outlier fences and see if there are any outliers. So let me come back up here and fix what I previously had on my key. So you can see down here, I computed the fences. I actually did that a little wrong, 62.3. I think I had some old data. And so I don't know what this ends up being, like 130 something, 130, let's say 135, it's something like that. And this was 62.3. This one ends up being, I think, negative 10-ish, okay, somewhere along those lines. So let's figure out how to determine if you have an outlier. If the maximum is above the upper fence, you know, because here's your fence at 135. So if the maximum is above your upper fence, you have an upper outlier. So you have at least one upper outlier. So I know I have at least one upper outlier. Then you have your negative is negative 10. Looking at the minimum, it is not below the lower fence because your outliers, your fence is down there. So in summary, for the outlier, you write that you have at least one upper outlier above 135 or whatever that number ended up being. All right, so the next one is you can see here that it is skewed to the right. So if it's skewed to the right, then we know that if you have skew, then you must choose to use median and IQR. Ooh. So we're going to end up using the median IQR. So I wrote that the shape is unimodal and skewed right. The center is the median at 8.25. The spread is the IQR of 12.1. So if I am using median and IQR, then the outlier rule that I should use is going to be, of course, the IQR outlier rule. So the upper fence is at Q3 plus 1.5 IQRs. It's at 36.55. And so we look at the max, and lo and behold, my maximum is above. So I've got data above the upper fence, so I have at least one upper outlier. And then my lower fence is negative, so it's way down here. My minimum is not below that, so I don't have a lower outlier. All right, and so then let's look at this last one. So this last one, I say it is fairly symmetrical, okay? So that's my first thing. And so since I have symmetry, standard deviation, and mean, so I'm going to be using the measure of center is the mean at 31.6, and the measure of spread is the standard deviation at 23.4. So my outlier rule I will use is the standard deviation outlier rule, mean plus 2 standard deviations. Brought that one up to 78.4. And the mean minus 2 standard deviations is a fence at negative 15. So let's see, my maximum is 71. That is not above the upper fence, so it does not appear to be any outliers because there's not a lower one either. All right, so that's the end of page 18, how to describe the distribution with your socks, shape, outlier, center, and spread. Now, let's take a look at this one. Lots of people had questions about this number 1 because what it's asking for you on number 1 is essentially we've got quarterbacks' salaries and either, so $58,750 or $89,354. One of them is the mean and one of them is the median. And so how do you tell? And the key to this is you have to know the shape of the distribution. And so to figure out that shape of the distribution, let's just kind of think about football players' salaries. And in this case, it's talking about quarterbacks. So say you've got 60,000 here, and then you've got maybe 100,000 here. But you know, out here, way far out here, you're going to have the millions and so on. And then, of course, here's your 0. So if you got, you know, you're going to have a lot of backups and that kind of thing. And so these are quarterbacks' salaries. You know, say you've got these ones around 60,000 and some of them are a little higher. And, you know, you might have a league minimum. And so maybe you have all these guys right here that have the league minimum. So I don't know. But there are a few quarterbacks that, you know, I don't know what Eli Manning's is, or I don't know who the top quarterback person is right now. But I know there's at least some, the most recent contract I saw was $25 million over 5 years. So we're talking, you've got some people that are way out here in upper outlier. So if you have got salaries that are, well, actually, if you've got salaries that are upper outliers, then the shape I have is what shape? And so then that shape is skewed right. That is the key to knowing the relationship between your mean and your median. Because remember, if you've got your mean, median, and if it's unimodal and you have your mode, okay, and you have it skewed right, think of your inequality. Skewed right, you've got this inequality, so that's the inequality you put in between the words, so you know that the mean is greater than the median. And if the mean is greater than the median, then you should be able to look at your data over here and say, oh, then this must be the mean, because the mean has to be greater. That average is pulled up because of those upper outliers. Now, on this, I want you to think of this stem and leaf plot as a sideways histogram. So think of these as your bars on a histogram. So, you know, turn your head sideways or turn your paper sideways and think of these as being the histogram bars. And if you do that, then you can envision that this is a slightly skewed right. And if it is slightly skewed right, then your mean is greater than the median. So that's how you can come up with the answer choice A. All right, number 3, if it's symmetric, if the left and right sides are mirror images of each other, that's true. If a distribution is spread far to the right, so that's stretched out here to the right, then that is skewed right. That is true. Tail right is skewed right. Okay, and then this next one, if a distribution is skewed to the right, its mean is greater than the median, and that is also true. So since all three statements are true, then none of these choices give the correct set of true responses. Okay, and then this last one, it is true that a stem plot, the number of leaves is equal to the number of pieces of data. And a dot plot and a stem plot, you can find outliers. That's true. Histograms do not retain the identity of the individual scores. That is true, because you have this, and if this is a range of data, you don't know the actual values in there. So so that's true, but it says dot plots, stem plots, and box plots all do. Actually, I learned this year that dot plots do retain individual data, because you would have, like, say, number 52, 53, 54, and you actually do put the dots on each of the pieces of data. Okay? But box plots definitely do not. When you have a box plot like this, you do not know the actual pieces of data that are in each quartile. So 1 and 2 are true, 3 is not. All right, now let's look at our outlier rules. So here on this outlier rule, okay, so we used the Iqr rule, which is for the upper fence, Q3 plus 1.5 times the Iqr. So I had come over here and figured out the Iqr for the females and the Iqr for the males, so that I could do this rule. When I did that, it came out to 26.35. And so I need to look at this maximum and see, is the maximum, here's the fence at 26.375. The maximum is 21. You want to know, is the maximum outside the fence? If it's outside the fence, above it, you have outliers. So since the maximum is not above that, no upper outliers. Then you identify your minimum. Your minimum ends up being here at 3.375, and your minimum or your lower fence is Q1 minus 1.5 Iqrs. When you calculate that at 3.375, your minimum is below that lower fence, so you do have, and here's what you have to say, at least one lower outlier. Because you don't know how many values you have. You've got a 2, you could have several 2s. You've got, you could have these other ones in between there. You do not know how many, you just have to say at least one lower outlier. Okay, then for our standard deviation rule, we're going to do the upper fence at the mean plus 2 standard deviations. And then the lower fence will be the mean minus 2 standard deviations. And the exact same way, once you get your fences, then you see if the max is above the upper fence, and it is not, and if the min is below the lower fence, and it is. So you have at least one lower outlier. Now you're going to do the same steps for the male data, same exact steps, and when you do this, you get these values for your fences, and you find that there are no upper or lower outliers for the male with the Iqr rule, no upper or lower outliers for the male standard deviation rule. All right, now, I do go over this page 21 through 25 tomorrow's video, except for I think when I go over that, I missed going over this number 5. So I wanted to talk to you about number 5 because I did not go over that on tomorrow's video. The key to this number 5 here is you have to pay really close attention to words such as population and sample and that kind of thing. And so let's talk about this. So number 5 says, given that a population has a standard deviation of 0. So for this, I want to pretend like our population is all of Aledo High School students, and we're talking about their GPA. Since standard deviation is that distance away from 0, average distance away from the mean. Sorry, I said that wrong. Since our standard deviation is the average distance from the mean, if the average distance from the mean is 0, then that means every piece of data is the mean. So I want us to imagine that this is the entire, and I know that's not realistic in real world, but let's imagine that the standard deviation for all Aledo High School student GPA is 0. That means every Aledo High School student has the same GPA. Okay, so I'm putting a big long stack because we have lots of Aledo High School students. And so this is all their GPAs that are all the same. All right, so now that we have that, let's go through our values. So the first question says, the standard deviation of a sample drawn from the population is also 0. Okay, well, I want you to think of picking a systematic sample. Maybe you pick a random starting point, and then you pick every 5th one. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So all of these blue marks make up the sample. Okay, so I have all of these ones as the sample. Well, is the standard deviation of all of these blue marks also 0? And that answer is yes, because they are all the same value, so they are all have the same 0 distance from the mean. Okay, number 2, I think this word sample right here is a little redundant. Think of it this way. The average of the sample that is drawn from the population is 0. Do you know that this GPA has a value of 0? And that's a no. You do not know that this is a value of 0, so it's not necessarily 0. Now let's talk about this last one here. The sample mean and the median are the same. And that's true. Look at these blue dots. Are these blue dots, which are the sample, do they have this same average? Yes. Do they have the same median? Yes, because they're all the same piece of data. They're all the same value. So therefore, 1 and 3 are true for that problem number 5. All right, so now I have finished going over all of those problems 18 through 20, and then this one on 21. So tomorrow's video goes through pages 21 to 25, which will prepare you for the quiz on chapters 4 and 5.